Hi, this is Ms. Fitzmaurice, and this is a video that should explain the multiple choice practice from tonight, which is August 28th. Okay, so in our first problem, it says shown below is the velocity versus time graph for a toy car moving along a straight line. What is the maximum displacement from the start for the toy car? Okay, we know that if you have velocity versus time and you want displacement, you have to find the area. Okay, so what you have to do, unless you're very good at finding the area of weird shapes, is break your shape up into a bunch of different rectangles and triangles. Okay, all of the area that I'm shading in right now is positive, so that's positive displacement. Afterwards, so this above the axis is positive. Afterwards, we're going to have some negative displacement, but the maximum will be when we're done with all the positive and we haven't shifted negative yet. Okay, so I'm going to go ahead and I'm going to find these areas. Okay, I have the numbers 2, 1, 2, and 4. Okay, this first rectangle, it's base times height, so the area is 2, which is 1 times 2. Right here we have a base of 1, a height from 2 to 4, so we have a triangle 1/2 the base height. 1/2 times 1 from 2 to 4 is 2, and this area is 1. Okay, the base here is 0.5. The height is 4, so we have a rectangle. 0.5 times 4 gives us 2. And then finally, we have another triangle. And for this triangle, we have 1/2. The base is from 1.5 to 2.5, so that's actually a base of 1. Again, height is 4, and we get an area of 2. Okay, now I'm going to add these all up. So I have 2 plus 2, which is 4, plus 1, which is 5, plus 2, which is 7. So the correct answer is 7 meters. In our second question, it says the graph represents the relationship between distance and time for an object that is moving along a straight line. What is the instantaneous speed of the object at t equals 5 seconds? Okay, so since it's a distance time graph, I know that my velocity is slope of my distance time graph. Okay, and I want the slope at 5 seconds. Okay, I can pick any 2 points on this line because 5 seconds is kind of the end of the straight line. The rise from 0 to 4 is 4. The run is 5, so my slope is rise over run, which is 4 meters per 5 seconds. If you divide that, that ends up being 0.8 meters per second, option B. Okay, on the other side, we have a graph which represents the position x versus t for an object being acted on by a constant force. The average speed during the interval is most nearly, and so to find average speed, remember v average is equal to x minus x naught over t minus t naught. Okay, between 1 and 2 seconds, so at 1 second, that's our x naught, it looks like our position is 2. At 2 seconds, it looks like our position is 8. So x minus x naught, remember the naught means initial, and we have 8 minus 2. And then in terms of time, 2 seconds minus 1 second, and we have 6 divided by 2, which is equal to 3 meters per second. Which seems to be wrong. So just a second. Between 1 second and 2 seconds, Sorry. 2 minus 1 is not 2, it's 1. 6 divided by 1 is 6, which is answer D. Sorry about that. Alright. Finally, it says starting from rest at time t equals 0, a car moves in a straight line with an acceleration given by the accompanying graph. Okay, so we haven't dealt with a lot of acceleration graphs, but you know that if you want to go from acceleration to velocity, you need to find slope. And it's asking for speed, which means we want, sorry, let me rephrase that because I said it incorrectly. Okay. If we're going from acceleration to velocity, we want area. Okay. We want the speed, so we want the velocity. Okay, so we want the speed at 3 seconds. Okay, and so we want this area that I'm shading in right now. We can break this area up into triangles and rectangles. Okay, this one is going to be 1/2 base times height. The base from 0 to 3 is 3. The height from 2 to 5 is also 3. So 1/2 times 3 times 3 is equal to 4.5. Down here we have a rectangle, base times height. Our base is 3, our height is 2. So we have 3 times 2, and that is equal to 6. Okay, to get the total velocity, we add these two together. Okay, and we have a total velocity of 10.5 meters per second. Okay, so again, going from acceleration to velocity, we find the area. We broke it up into two separate areas and added them together. 6 plus 4.5 is 10.5 meters per second.